Hello and welcome to my channel. Let's continue solving some examples about how to draw shear force diagram and bending moment diagram. In this video we have a simply supported beam, pin joint and roller joint with a distributed load with a trapezoidal shape. Look like this. Starting at 10 kilonewton per meter and ending at 30 kilonewton per meter, and has a length of 6 meters. Okay, as usual, step 1 is to calculate support reaction. For this beam we have two support reactions. Actually we have three, but one of them is 0. This is distributed load. Kilonewton over meter, 10 kilonewton over meter, and let's call this point as A and this point as B. Then we have Fy at A, Fy at B, Fx at A, and we don't have any moments. Okay, so summation Fx equals 0, that means Fx at A equals 0. Then summation Fy equals 0, that means Fy at A plus Fy at B minus the distributed load will equal 0. So the distributed load here is a trapezoid shape. This length is 6 meters. Actually, you have two options. You can split this trapezoidal shape into two parts, one rectangular and one triangular, and solve each one separately, or you can use it as trapezoid as it is, and you know how to calculate the area of a trapezium. Base 1 plus base 2 over 2 times 6 meters, the height. This is one option, and the second option is to split it into two parts, one triangular and one rectangular. I usually prefer to split it into two parts, triangle and rectangle, and that is because while calculating the moment, bending moment function. Okay, so let's do this. So we have two parts, the rectangular shape and triangular shape. So the rectangular shape, its area is 6 times 10, right? 6 times 10. And the triangular shape is half, and the base is 6 times the height. In this case, this height should be 30 minus 10, 20 kilonewton per meter, right? 20. And that means Fy A, Fy B, so this should be equal 0, equals, this is 60 plus 60 as well, so this would be 120. Okay, so Fy A, Fy B equals 120. Okay, so let's take the moment about point A. Summation moment equals 0. That means summation moment at A equals 0. So at point A, let's draw the forces we have here on the side. This is point A, this is point B, and we have here FYB, FYA. For sure FYA will not be included in this equation, but the important is this trapezoid shape. I will make it a little bit bigger so you can see how splitting the trapezoid works. So this is 10, this is 30. Okay, so for the triangular part, the concentrated load equivalent to this distributed load will be acting somewhere here. One over 3 times 6 meters. This is 6 meters. So this should be 2 meters. But for the rectangular shape, it should be in the midpoint right here. 3 meters. Okay? How much is it? For the rectangle, it is 60 kilonewton. For the triangle, it is also 60 kilonewton. And this is by chance. Okay. Okay, so let's take the moment about point A. For these forces, you have the 60 kilonewton, and the FYB. Okay, so the Fy at point B times 6. Okay, this will be counterclockwise, positive value, and then minus 60 times 3 minus 60 times 4. This will be equal to 0, right? Okay, so then solving FYB, this will be equal to how much is this? 70, right? Okay, going back to the Fy equation, then Fy at A will be 50. Okay. Okay, let's move to the second step. Get the shear force and bending moment functions. And as we did before, we will cut the beam. So this is a beam, and this is a distributed load, 30, 10, and we have here two reaction forces. At A it is 50, and here it is 70. Okay, and that's it. And we want to cut this, let's say, from here. So we will have the beam like this, a little bit shorter, and 50. Okay, and you have the shear V and moment M. Okay, and the question is, how much is this point? So this is 10, but we don't know how much is this. And the answer is, to calculate how much is this height, so you have 20 over 6 times x. X is this distance. Okay, always you will take the 20, which is this height, the 20, okay, over the length, 6, times the distance, which in this case is x. Okay, this will give you the new height here. Okay, so solve the equation of equilibriums. Summation f y equals 0. So you have $50 upward, and you have two other point loads from the two distributed loads. So the two distributed loads, one is rectangular and one is triangular. So the rectangular will be right here, and the triangular will be right here. The value of each one is, the area of the rectangle is 10x. The area of the triangle is half. Let me write it down like this: half base x times the height, 20 over 6x. Okay, and these both are downward, so negative 10x, negative half x, 20 over 6x. Okay, and then minus shear force V. this should be equal 0. So from here you can calculate the V, or to find the V is equal to 50 minus 10x, and minus this will be 10 5 over 3 x squared. Okay, let's do the moment. For the moment equation, summation moment about z equals 0, and usually I like to take the moment about the cut point, and the distance here is half x, 1 over 2x, and here is 1 over 3x. Okay, so moment about this point, then we have m, and for the 50 it is negative 50 times x, and then positive 10x times half x, and then positive that was 5 over 3 x squared times 1 over 3x. Okay, these are all the forces we have, and equals 0, then m is equal to 50x, and you have here negative 5 x squared, and this should be negative 5 over 9 x cubed. Okay, third step is to draw. Draw shear force and bending moment diagrams. This is the beam, pin support, roller support, and distributed load. And this length was 6 meters. Here will be the shear, and here will be the moment. Shear, V, positive, negative, moment, M, positive, negative, and the equations was the shear equals 50 minus 10x minus 5 over 3x squared, and the moment was 50x minus 5x squared minus 5 over 9x cubed. Okay, so let's start drawing this. At x equals 0 for the shear, you will get 50, right? Positive kilonewton. And for x equals 6, so you will have here 50 minus 60 minus 5 over 3, 36. This will be 12, 60, negative 70. Okay, so this would be negative somewhere here, negative 70. And this should be intersecting with the horizontal axis, and to get the intersection you will equate this equation to 0 to find x, and in this case x will be 3.2, somewhere very close to the midpoint of the beam, 3.245. So you will equate the equation of the shear to 0 and solve for x to find how much is x for shear equals 0. Okay, so the shape of the function should be parabolic, x squared, so it will look like this. Let's go to the moment. At x equals 0, the moment is equal 0. At x equal 6, so this should be 300 minus 5 times 36, 5 over 9, 36. Using your calculator, this should be 0 as well. Okay, and then let's find how much is the moment for x equal 3.245. At this point. It would be equal 90.6. So it would be somewhere here. Let's say 90.6. Then it has a cubic equation, x to the power 3. So it would be something like this. And that's it. Now we have the shear force diagram and bending moment diagram.